Hello, this video is for IXL activity 7.R.5. It is titled Evaluate Multivariable Expressions. So by multi means we're going to have more than one variable, which we see in this first problem here where f is equal to 6 and g is equal to 3. The 3-character code for this that IXL uses is Tango 56, T56. So, in the discussion that we had in the Lesson 1, Chapter 1 video, we learned that the word evaluate means to actually get an answer, to come up with a solution. But in order to evaluate a variable expression, we have to plug these values in for what we're given in the expression here. So on this first one here, let's take f, and f is equal to 6. So we're going to write this as 6, and then we bring down the subtraction sign. And then whatever g is, we write in for that, and that happens to be 3. So in this case, 6 minus 3 is 2. Now you might be saying, is that all there is to it? Indeed, that's pretty much it. The idea here is to get a grasp on the idea of what does it mean to evaluate. Now, in here, we're going to have some order operation discussions, and we're also going to have some talk about what are exponents, bases, and powers, and what do those mean. So hopefully you're good to go on those things. If not, there's other places that you can review for that, but you'll get some of the instruction here. Hopefully, if you just need a refresher and a reminder, that'll help you out. So let's look at our next couple problems here on the next one. It is up here on this top question. Evaluate the expression for P equals 2 and Q equals 3. So we have PQ here. And notice that there's no operation sign in between here. So we know that it is, well, hopefully you'll recognize that as that this is going to be multiplication, right? So we need to multiply. So we're going to go ahead and substitute for P. We have 3, and we need to multiply that. I'm going to use a dot instead of the x. Don't want to confuse it as a variable x. So 3 times whatever Q is, and Q is, oh, I take that back. I got caught up, and I'm a little bit dyslexic at times, and so I got that P and Q. They kind of look the same to me. P is 2, right? So, and times, and then the Q is 3. So in this case, we're going to have 2 times 3, and that is 6. So we just type in 6 and hit enter. On the next question down here, the expression, evaluate the expression for R is 1 and S is 5. Now, notice that I use the word is for the equal sign. It's the same as saying equals. I could say R is 1 or R equals 1. Same difference. So R is 1, and again, no operation sign here, so we know it's multiplication. So we need to multiply that times 5 because S is 5, and 1 times 5 is 5. So type in 5 and hit enter, and we're good to go. On the next one here, let's see, we're going to have a talk about multiplying and dividing negative numbers because I got a -1 here, right? So n times p minus n. So let's go ahead and first substitute in our values so that we can evaluate it. N is -1. P, I'm going to use parentheses to separate the -1 and the 8. So I'll put that 8 in there. And then from that, I'm going to subtract, and whatever n is -1. Now, here's a tricky spot right here. Notice that I bring down the subtraction sign here. Now, I'm going to use parentheses to hold the value of n, which is -1, because this 1 has a negative sign with it, which is going to interact with the subtraction sign a little awkward. So let's first deal with the -1 times 8 first. So -1 times 8. Well, 1 times 8 is 8. But a negative times a positive equals a negative. So a negative times a negative equals a positive. We already know that a positive times a positive. I guess I should have started off at that. We know that positive times a positive equals positive. And a negative times a negative equals positive. So if the signs are the same, it's going to be positive. However, if we have a negative times a positive, or a positive times a negative, then both of these are going to equal a negative themselves. So a little bit of a quick refresher there on that. So 1 times 8 is 8, and it is a negative times a positive, so that's going to be negative. Now I have this minus negative 1. Well, minus means take away, but we can also read it as the opposite of. So minus a minus is equal to the same as plus a positive. So in that little trick there, let's take those few steps away. So I can change the sign from subtraction to addition and take the opposite of the value that follows the subtraction sign. So the opposite of negative 1 is positive 1. Comes out the same either way. And negative 8 plus 1, well, if we're on a number line, we're down here at negative 8, and we're going to add 1. Here's 0 down here. We're adding, so we're going this direction, but we're only going one spot, so that's going to be negative 7. So negative 8, add 1 to negative 8, we're going to get negative 7. Evaluate the expression for r equals 0 and s equals negative 3. So r is 0, going to multiply that times the negative 3, and I'm going to put this in parentheses to hold it. There's no sign there right here between the 0 and the negative 3, so I know that that is multiplication. Throw that 3 back in there. And then I'm going to add to it the value of s, which is negative 3. So now I have here 0 times negative 3. Well, hopefully we know that anything times 0 is 0. If we multiply any value by 0, whether it's positive or negative, we're going to get 0. And then we add negative 3. So we're on a number line, we're at 0, and we're adding a negative 3, which means we're going back, whereas here to negative 3, and our answer is going to be negative 3. Throw that in there. But here's something that I want to show you again. The same way up here is where I changed the sign to addition, but I just took the opposite of the number that follows. I could do 0, change the addition to subtraction, and then take the opposite of the number following the sign that I changed, and the opposite of negative 3 is 3, so we could look at this as 3 minus 0 also equals negative 3 as well. Either way, it'll work out. On the next one here, we want to go ahead and take the 2. I'm going to put a number in for n. I'm going to put a number in for p, and I'm going to do plus whatever n is. Now, I like to encourage my students to get used to this. Notice all I did was I rewrote this expression right here, and like it was, but wherever there was a variable, I put parentheses in. That's because I'm going to use those parentheses to hold those values. So n is 7, p is negative 2, and here n is 7 again. So let's go ahead, and we need to do the multiplication first over here. Pemdas, right? Please excuse my dear Aunt Sally. If you're not familiar with this, this is order operations. It lets us know to do whatever's in parentheses first. Then we have to do exponents. Then we have to do all multiplication and division going from left to right. And then we do all the addition and subtraction going from left to right as well. So that's the order. So we have no parentheses except for the ones that I'm using to hold the numbers, but that's something totally different. And I have no exponents in there, but I do have some multiplication and division. So that's all this right here is multiplication. So notice I have to take care of the multiplication first before I can address this addition that's here. So 2 times 7 is 14, and I still have the negative 2, and bring down the positive 7. I'm going to do this each step. Now 14 times negative 2, well, 14 times 2 is 28. And like we talked about on the previous page over here about multiplying and dividing positive and negative numbers, here I have a positive times a negative, so it's going to be negative. And then plus, and now I'm going to take that 7 out of that parenthesis there, And now I need to know negative 28 plus 7. So if I'm on a number line and I'm down here at negative 28 and I'm going to add 7, going back this way, plus 7, it's not enough to get me to 0, is it? So it's going to be someplace back there. And so 28, and as I go back this way, it's going to be negative 28, negative 27, negative 26, negative 25, negative 24, negative 23, etc., right? Well, we're going back this way. Notice that the number is going this way. This was at negative 23. So to find out which one we're going to land at, we kind of have to subtract 7 from the negative 28, or from 28, and that's going to give us 21. And then we eventually get here at negative 21. So you see that's 1, 2, 3, 4, 5, 6, 7. So we're going to land here at negative 21. There are activities on IXL that you can practice adding and subtracting integers. Integers are the positive and negative, the whole numbers, numbers that are not decimals. Right? So you can always practice, find those, and give it a practice shot on that. Chances are that they're in homework for the future anyhow. So, and also by the time on IXL, by the time you get to these problems, you're already up in about the 60s anyhow. So you've got kind of got a passing score, and you can always go back later on whenever we cover lessons on adding and subtracting integers and dealing with multiplying and dividing negative numbers. You can always come back to this and improve your scores on this as well if you're having any difficulty, if you're having a hard time with some of this stuff. We'll be addressing it in more detail later in the future. So on the next one, evaluate the expression for t equals negative 5, or t equals 1.5 and u equals 12. So here I'm going to rewrite. Once again, good advice is to just rewrite it and use parentheses for the variables. Then plug them in. So t equals 1.5 and u equals 12. Well, to be honest with you, I'm going to go ahead and I'm going to use my calculator for this one. So I'm going to go ahead and do 16.3, and I'm going to multiply that times 1.5, and that's going to give me 24.45. 24.45. And I'm going to add to that 12. So I'm just going to go ahead and pull that 12 out of the parentheses there. And then I can add these two values together to get their sum, or the total. Both words refer to addition. And on this one here, at this 12 were decimal, the second value here, 12 was decimal. I might use the calculator, but I think I can handle it. I know that we're still going to have the 0.45, right? And I'm just adding. Now it's like 12 plus 24. Well, 24 plus 12, well, 10 of it. 12 is the same as, what, 10 plus 2? So let's 24 plus 10 is 34, plus 2 more is 36. So my answer would be 36.45. Looking at my next problem here, got exponents here. So remember back on that one page, there it is. Please excuse my dear Aunt Sally. We're going to have to deal with the exponents first on this one, all right? So looking at this, I will first go ahead and rewrite this just like I see it, but instead of the variables, I'm going to put parentheses. Now I'm going to plug stuff in. So R has a value of 3, S has a value of negative 5, and Q has a value of 13. So I have an exponent right here, right, at that 3 squared. So what exponents mean is that means that whenever the exponent is this little like superscript, the little 2 up here, it's kind of raised up higher. And what that means is that I have to multiply this number here, which is the base, by itself, or to itself, the number of times that the 2 is here. So 3 squared equals 3 times 3. Notice that I've taken the base that we see here, and how many times am I multiplying it times itself? Twice. So 3 times 3 is 9. Now I need to multiply that times the negative 5 and also add the 13. Now 9 times negative 5 is negative 45. 9 times 5 is 45. Positive times negative is negative. Now I'm going to add to that 13. And later on, we'll also realize that whenever we're adding and subtracting positive and negative numbers, there is kind of a little trick to it. And what that trick is that if they have the same, like if we have two positive numbers, right? Positive, and let's see, the plus signs might get confusing. Let's use P for positive and N for negative. So a positive plus a positive is going to equal a positive. And a negative plus a negative is going to equal a negative. However, negative plus positive or positive plus negative, on that one there, it could be one or the other. It could be P or it could be N, either way. And there is a way to tell, and it's through absolute value. And absolute value is another lesson in of itself, but think of it as what is the greater value. If we didn't have the subtraction sign, which number has the greatest value? So in this case here, and also we have to change it to subtraction. That's kind of something I left out there. And so instead of 45 plus 13, think of it as 45 minus 13. So let's see how that works out. Well, 45 minus 13. Well, 13 is 10 plus 3, right? So 45 minus 10 is 35. Minus 3 more is 32. But the question is that a negative 32 or is that a positive 32? Well, there's a couple ways you could think of it. First of all, if we're at negative 45 and we're adding 13 to it, it's not going to be enough to get us to 0, is it? So obviously it's going to land someplace here in negative land. It's not quite far enough, and as we know, that number's 32, right? So it's not quite enough to get us back to 0 to get us back up here over into all the positive numbers. So that's one way to tell of thinking, oh, it's negative. But also notice that if neither of these were negative numbers, the 45 would have greater value. That's absolute value. We'll get into discussions about that whenever we have a class on absolute value. So since the absolute value is negative, the number that has the greatest absolute value, or the greatest value if there were no negative sign, then whatever sign that number is wins out. So in this case, 45 is greater than 13, so 45 is negative, so the answer is negative. We'll get there someday. So evaluate the expression for P is negative 12, Q is negative 2, and R is negative 2.8. Yay, more decimals, right? So let's go ahead and take our P times the Q, and it is squared, and then we're going to subtract whatever R is. So we've rewritten it using parentheses. Let's plug those numbers in. So P is negative 12, R is negative 2, and R, oh, I messed up, didn't I? Go back. Come on, Mr. T. You gotta know what you're doing there. There we go. Q is Q is negative 2. Silly me. I had it right. And R is negative 2.8. Negative 2.8. All right, so let's deal with this exponent first. Remember, please excuse my dear Aunt Sally. So I need to take care of parentheses. Don't have those, but I do have an exponent, so I need to do that first. So let's take this negative 12 and just bring it down for now. And then this negative 2 times negative 2 is going to be, oh, give me some room to work here. So negative 2, right, squared. That is equal to, and since the negative sign's inside of the parentheses, that is negative 2 times negative 2. It's the base, negative 2, twice. Multiply times itself. And here we have 2 times 2 is 4, and remember, negative times negative equals a positive, so this is a positive 4 right there. And let's bring down our minus 2.8. However, this is a negative 2.8, so I don't want to do minus a minus. I would rather plus a positive. So I'm going to change the subtraction to addition, then take the opposite of this value here, and that's a negative 2.8, so I'm going to now make it a positive 2.8. Let's get rid of the negative sign. Next step, I got to deal with the multiplication before I can do the addition here, right? So let's do this multiplication right here on this part. 12 times 4. Well, negative 12 times 4 to be exact. And that is, 12 is the same as 10 plus 2, right? So 10 plus 2. So 4 times the 10 is 40. And 4 times 2 is 8. So 40 plus 8 is 48. And now add to that 2.8. I think I can do that one without a calculator. So I know I'm going to have the 0.8, right? Because there's nothing after the over here with the 48, no decimal there. So I'm going to have the 0.8. Now 48 plus 2, well, that's easy enough. That's 50. So my solution is going to be 50.8. I strongly encourage you to do this on paper. Get a piece of scratch paper and work it out. I know that you don't have to turn in or show your work. You just simply have to enter the values in and submit your work through a digital format, through IXL. Many students of mine often think that, oh, that means I don't need to use paper, but you definitely want to use paper to kind of keep track of. And this is a lot of stuff to keep in your head, so get used to doing that. All right. It's been a little lengthy, but got a couple more problems here. We're running just over 20 minutes now. I like try to keep them less than 20, but a little longer today. So in this case here, I have b times c plus b times d. So let's go ahead and write that out. Parenthesis, parenthesis, b and c. Going to add to that whatever b and d is. And I see I got some negatives. I got some decimals. Yay, what fun, right? So b is negative 4, and c is negative 7.7. I should make my parentheses just a little bigger. And here b again is negative 4, and d is negative 4 as well. Well, okay. Don't see that too often when they make them the same. So let's take care. We have multiplication here, and we're going to have to do each of those sides before we deal with this addition here. So negative 4 times negative 7.7. Well, it is negative times negative, so I know it's going to be a positive. That's good. And 4 times 7.7. I could get my calculator out, but let's do that over here to the side. 7.7 times 4. We're going to use that old algorithm there, and this is multiplication. So 4 times 7 is 28, and we're going to carry the 2. And then 4 times 7 again is 28, and add the 2, and that's going to give us 30. So using the standard algorithm for multiplying 2 digits by 1, we get 308. Now we look at, we got to deal with the decimal. And here there's one number behind the decimal. And here there's no decimal, so we have 0, and 1 plus 0 is 1. So we need to move the decimal over one place here, and we would get 30.8. So on my first side here, I have 30.8. Again, that is negative times negative, so it's positive. And let's bring down our plus sign here. And then negative 4 times negative 4. Well, I know that 4 times 4 is 16. And it is a negative times negative, so it's going to make a positive. Good to go there. And I can add this decimal number, this whole number, not too difficult. I know I'm going to have the 0.8. It's still going to be there because there's no decimal portion of this value 16. And then I got 30 plus 16. And my mental math for that is 16 is the same as 10 plus 6. And 30 plus 10, 30 here, plus the 10 is 40. Plus 6 more is 46. So my final solution would be 46.8. All right, one last problem here. This one looks like a lot of fun. Don't it? We've already been given one value here. This is what we call a constant, right? It has no, we'll get there later. So we got the 5.5 already there. H is 7.4 and J is negative 6. So we're going to have some negative numbers. We're probably going to have some sign changing. We do have some multiplication that we have to take care of before we get to the addition. So we'll look at that. So let's go ahead and rewrite this using the parenthesis process here. I'm just rewriting the whole thing out and using parentheses. So now let's plug it in. H times J. So H here, J there, H is 7.4. And J is negative 6. And then j again is -6. And we already had the 5.5. So we need to take care of that multiplication right here first. So 7.4 times -6. Well, it is a positive times a negative, so it's going to be a negative number. I know that already. And I'm going to do that 7.4 times 6. I'll go ahead and model that standard algorithm. We do the 6 times 4 here. So this number times that number. 6 times 4 is 24, and then we carry the 2. And 6 times 7 is 42. And add to what we carried over here. So 42 plus 2 is 44. So it looks like we have 444. Now we have one decimal here, one number behind the decimal here, and none here. 1 plus 0 is 1. So we're going to move that decimal over one place, and we'll end up with 44.4. So let's go ahead and put that over here, and that is a negative 44.4. And then we got minus a negative. Well, I don't want a minus a negative. I'd rather plus a positive, and that works out. So let's change that sign, right? And then let's take the opposite of -6, which is +6, and then bring down our minus 5.5, right? So as I look at this, I now have to, I could just add straight across. I took care of the multiplication. Now I just have the adding to do. I could do the -44 and add 6 to it, but I'm focused on this right here, this portion here. All of a sudden I spot this might be not too bad, right? 6 minus 5.5, or like 5.5, right? Well, 5.5 is only halfway, is 1/2 to 6. So if we take that value there, it equals 0.5. And I can show you that over here, just to be sure. I'd have to do 6.0 because I'm adding or subtracting decimals, so I need to line my decimals up. That's the key thing about adding and subtracting decimals. You want to line those decimals up, unlike multiplication where you don't have to line them up. So this looks, now you can see 60 minus 55. Well, it's going to equal 5. Right? Or I could say, can't take 5 away from 0, so I need to borrow 1 from 6 here and turn that into 10, and now the 6 becomes a 5. And 10 minus 5 is 5, and 5 minus 5 is 0, and the decimals stay right where they're lined up there, so 0.5, right? Now I have negative 44.4 plus 0.5. Well, on the number line there, I'm at negative 44.4. There I go. Adding to it 0.5. So I'm going back this way, right? But I'm only going back half. And one way to think of that is, let's just line that up. We need to know, let's use that idea of, instead, let's subtract them, and let's let the number with the greater value win out on the sign, right? So on this one here, I could set 44.4. And since I'm subtracting decimals, add and subtract, line those decimals up. And I'm going to find the difference. That means to subtract. So I can't take 5 from 4. So I need to borrow 1 from here, change that to a 3, and add it, that 10 over there. 10 plus 4 is 14. Now I can do 14 minus 5 is 9. And then I have nothing else here, so I just bring down that 3 and bring down that 4. And I need the decimal that lines up there. So I'm going to end up with 43.9. And since the 44.4, if we weren't even paying attention to the negative sign there, and again, that's a discussion about absolute value. We'll look at that closer in the future. But the 44.4 would be greater than the 0.5. So the 44.4 is negative, so we make our answer negative as well. So we have negative 43.9. All right. So if we look back at the first slide there, we see that our objective today, even though we had a whole lot of Pemdas in there, there's a bunch of stuff about exponents, and we had multiplying negative and positive numbers, and adding negative integers together, and a whole bunch of other stuff we're going to get to later. The idea was here is to understand that it's all about understanding that evaluate means to substitute the values in and then do the math to actually come up with an answer to the expression that we're given here. Again, the other stuff that we looked at, if you're having difficulty or if you have difficulty with it as you try to do the activity, don't worry about it. You can always later on, once we learn those concepts, you can always go back and increase your score for this activity. All right, so there you have it. IXL 7.R.5, a little long, about 30-minute video there. Didn't mean to go so long, but it is evaluate multivariable expressions. Good luck with your activity.